Hey, welcome to The Explainer, where we try to make big ideas a little less, well, big. So today, we're going to talk about this hidden rule of math, one you've probably used a million times without even thinking about it.
All right, let's kick things off with a little mental challenge. How would you, right now, in your head, solve 30 times 20?
So if you're like most people, you probably did something like this. You saw 20 and thought, hey, that's just 2 times 10. Then you kind of shuffled things around in your head. You probably did 30 times 2 first, that's an easy 60, and then just tacked on a 0 by multiplying by 10. Boom, 600. It's a great little shortcut, right?
But hold on a second. We just did that without blinking. But why are we allowed to do it? I mean, what rule in the big book of mathematics gives us the green light to just regroup numbers like that? Who gave us permission?
Okay, so here's what we're going to do. We're going to give this sneaky shortcut a proper name. Then we'll figure out where it works and, just as importantly, where it totally breaks down. And stick around because by the end, you'll see why this isn't just a party trick, it's actually a pillar of modern math.
So that magic trick that lets us do our mental math? Well, it has a name. It's called the associative property.
And the name kind of gives it away, right? It's all about who you associate with, or, which numbers you group together. Those parentheses are just telling us, hey, do this part first. And what the associative property says is, look, for addition and multiplication, it really doesn't matter who you group up with first. The final answer is going to be exactly the same.
Now, this is where a lot of people get tripped up. It's super easy to mix up the associative property with its close cousin, the commutative property. Just remember this. Commutative is about commuting or moving the numbers around, reordering them. Associative is all about changing the association or the grouping. The numbers themselves stay in the same order, we're just moving the parentheses.
And this confusion probably starts way back in grade school. We're often taught this sort of general add 'em up any way you want rule, and that kind of mushes these two totally separate ideas, reordering and regrouping, into one big concept, which, believe me, can cause some real headaches later on.
Okay, so let's get really clear about this. Where does this rule actually work? Well, for starters, it works perfectly with addition. Let's take a look. If you group the 3 and the 1 first, you get 4. And 4 plus 5 is 9. Easy. Now, what if we group the 1 and the 5 first? That gives us 6, and 3 plus 6 is, you guessed it, 9. The final sum is exactly the same. No surprises here. And it's the same story for multiplication. This is a really cool visual, actually. A class used this grid or array to see what happens. You've got 4 times 8, right? The area is 32. Now, if you regroup things and double that 8 to 16, look what happens to the total area. It doubles to 64. It's a fantastic way to actually see that regrouping the multiplication doesn't change the final outcome. Okay, so it works for whole numbers. But what about the messy ones? What about more complex numbers, like fractions?
Yep, you bet it holds true. It might look a little scarier with fractions, but the rule doesn't care. Whether we add 1/2 and 3/4 first, or if we decide to add 3/4 and 5/6 first, once you do all the work of finding common denominators and adding it all up, you land on the exact same answer, 25/12. The results match perfectly.
All right, so we've seen where it works. Now for the fun part. Where does this whole thing fall apart? Because trust me, this powerful little rule definitely has its limits.
And here is Exhibit A, subtraction. This is so important. With subtraction, how you group the numbers completely changes the game. Look, if you do 4 minus 2 first, you get 2. Then 2 minus 1 is 1. Simple enough. But what if you group the 2 minus 1 first? That's 1. And 4 minus 1 is 3. And last I checked, 1 and 3 are not the same number. So subtraction is not associative. Big red X.
Division fails the test too, in an even more spectacular fashion. If we group the 100 and the 10, we get 10, and 10 divided by 5 is 2. Okay, now let's switch it up. Group the 10 and the 5. That gives us 2, and 100 divided by 2 is 50. 2 versus 50, yeah, that's not even close. So division is definitely not associative either.
Okay, so we've established it's a special rule just for addition and multiplication. But why should you care? Is it just a neat trick for mental math? No way. It's so much bigger than that. This rule actually helps define the very nature of what these operations are. See, properties like this aren't just things mathematicians noticed one day. They're not just observations, they are the actual rules of the game. They are the fundamental axioms that tell us how algebra and numbers are supposed to behave. And in higher level math, when you get a number system where the operations follow a specific set of these rules like commutativity, and you guessed it, associativity, you have something really special. It's called a field. Think of it like a perfectly balanced playground where all the arithmetic works exactly how you'd expect it to. It's consistent, it's predictable. And this chart is a great way to see this in action. It shows us exactly why fractions, or rational numbers, form a field, but integers don't. See, to be a field, every number that isn't zero needs to have a buddy, a multiplicative inverse, basically a reciprocal, that's also in the system. Integers fail this test. The reciprocal of 2 is 1/2, but 1/2 isn't an integer. With fractions, though, no problem. The reciprocal of any fraction is just that fraction flipped upside down. So let's bring this full circle back to our mental math trick from the very beginning. The reason that shortcut works, the reason we can regroup those numbers with total confidence, is because we are playing inside a mathematical field. The numbers we were using, and multiplication itself, follow all these beautiful, consistent rules, including the associative property. It's not a fluke. It's guaranteed to work. And that kind of leaves us with a pretty interesting question, doesn't it? A simple rule like regrouping feels so obvious, so fundamental, right up until the moment it completely breaks down for subtraction and division. It really makes you stop and think, what other obvious rules of math that we take for granted aren't nearly as simple as they seem? Thanks for digging into this with us on The Explainer.